Hey there guys, welcome to my walkthrough of the Edexcel A-Level Maths Sample Paper 1 for the new specification. So paper 1 is pure maths, the paper and mark scheme and formula booklet will be down below. Let's do this. Okay, number 1, the curve C has equation y equals 3x to the power 4 minus 8x cubed minus 3. Part 1 wants us to find dy by dx. Okay, so we are differentiating. So 3x to the power 4 becomes 4 times 3x to the power 3, so 12x cubed. And then minus 8x cubed becomes minus 24x squared. Okay, then part 2 wants us to find d squared y over dx squared. So the second derivative. So 12x cubed is gonna differentiate to 36x squared. And then minus 24x squared is going to become minus 48x. Cool. Okay, then part B wants us to verify that C has a stationary point when x equals 2. So at stationary points, dy by dx is equal to 0. So let's see what we get when we substitute x equals 2 into dy by dx. So when x equals 2, dy by dx is 12 times 2 cubed, which is 12 times 8, which is 96. And then we have minus 24 times 2 squared. 24 times 4 is 96. So we have 96 minus 96, which is equal to 0. Okay, then part C wants us to determine the nature of this stationary point, giving a reason for your answer. Okay, so for that then, we use the second derivative. So when x equals 2, d squared y by dx squared is 36 times 4, which is 144. Minus 48 times 2. so minus 96. Now that is 48. Now, 48 is greater than 0. Now, when the second derivative is greater than 0 at a stationary point, that point is a minimum. Okay, number 2, fun with sectors. So the shape ABCDOA, as shown in figure 1, consists of a sector COD, of a circle centre O, and that's joined to a sector AOB of a different circle still centred at O. Given that the arc length CD is 3 centimeters, angle COD is 0.4 radians, and AOD is a straight line of length 12 centimeters, part A, find the length of OD. Okay, so OD is this line here. So what do we know about this sector? Well, we know its arc length and we know its angle. What we're trying to find is its radius. So the formula for arc length is usually S is equal to R theta. So for us, we get 3 is equal to 0.4 R. Divide by 0.4. We get R is equal to 7.5 centimeters. So we now know that this length is 7.5, which also then tells us this is 4.5. Okay then, for part B, we want to find the area of the shaded sector AOB. So, to find the area of a sector, the formula is 1/2 times the radius squared times the angle, so half R squared theta. So, for us, we know R is now 4.5. We know that AOD is a straight line, so the two angles in the centre have to add up to pi. So that means this angle is pi minus 0.4. So, our area then is 1/2 times 4.5 squared times pi minus 0.4. And then for that, we should get 27.76 centimeters squared. Okay, number 3. We circle C as equation x squared add y squared minus 4x add 10y equals k, where k is a constant. Part A wants us to find the coordinates of the centre of C. Okay, so, bit of revision. So, we circle centred AB. Radius R has equation x minus a squared add y minus b squared is equal to r squared. So we need to write this in that form. So let's rewrite it first of all as x squared minus 4x add y squared add 10y is equal to k. Now we need to complete the square twice, once for the x, once for the y. So we're going to get x minus 2 squared minus 4 add y add 5 squared minus 25, and that's equal to k. Now on the left we have x minus 2 squared add y add 5 squared minus 29 is equal to k. So if we add 29, we get on the right k add 29. Now from that one, we can get that the centre is positive 2 minus 5. Okay, then part B wants us to state the range of possible values of k. Okay, so we know on the right, when we now have k add 29, that is the radius squared. Now that means then that k add 29 must be greater than 0. because you are squaring the radius, even r itself has to be greater than 0 because it's the radius of a circle. So, if we then just subtract 29, we get k must be greater than minus 29. Okay, number 4. So given that a is a positive constant and the integral between a and 2a of t add 1 over t with respect to t equals log 7, we want to show that a equals log k, where k is a constant to be found times. Okay, so what we need to do then is integrate that integral and substitute in the values and set it equal to log 7 and then find k. So first thing we need to realise is that t add 1 over t can be written as t over t add 1 over t, which is 1 add 1 over t. So then we are integrating between a and 2a. 1 add 1 over t with respect to t. Now that then is going to give us t add log t between 2a and a. Okay, so when we sum in the limits, we are going to get two a add log of 2a minus a add log a. Now we know that that is equal to log 7. So we have then we have 2a minus a, which is going to leave us with 1a, and we have a log of 2a minus log of a. Now, by the subtraction law of logs, log 2a minus log a is log of 2a divided by a, so that's just log of 2. Now we know that is equal to log of 7. Now if we subtract log 2, we get a is a log 7 minus a log 2. Now that is a log of 7 halves. Now remember, we wanted to show that a equals log k. So we now know then that k is 7/2. And there it all is in one place. Okay, number 5. A curve C has parametric equations x equals 2t minus 1 and y equals 4t minus 7 add 3 over t, where t is not equal to 0. We want to show that the Cartesian equation, so that just means in terms of x and y, no t, of the curve C can be written in the form y equals 2x squared add ax add b over x add 1, where a and b are integers to be found. Okay, so it's basically simultaneous equations, although because there are 3 variables, it's more like simultaneous formulas. So what we can do is rearrange the equation for x to get t on its own, so get t in terms of x, and then substitute that into y, and then do some magic. So if x is equal to 2t minus 1, we can rearrange that to get that t equals x add 1 over 2. So then from that, y then is equal to 4 lots of that minus 7 add 3 over x add 1 over 2. Okay, so we're now playing around with this. Alright, so first step, the 4 and the 2 cancel a bit, so we're just left with 2 lots of x add 1, so that's 2x add 2. And then we got minus 7. Now over here then, we have 3 divided by x add 1 over 2. So when you're dividing by a fraction, you flip it over and multiply by it. So we're going to get 6 over x add 1. Okay, so we can simplify the first bit to 2x minus 5. So we have 2x minus 5 add 6 over x add 1. Okay, so we now need to combine this into a single fraction. So, to do that, I'm going to go down the old common denominator route. So, I'm going to multiply 2x minus 5 by x add 1 over x add 1. Okay, so now because we have common denominators, we can just write this as a single fraction. Now I'm also going to expand the brackets. So we are going to get 2x squared we're going to get minus 5x add 2x minus 5 and then add 6 all over x add 1. So then finally y is 2x squared minus 3x add 1 all over x add 1. Boom. Okay, so again, there it all is in one place. Number 6. A company plans to extract oil from an oil field. The daily volume of oil V measured in barrels that the company will extract from this oil field depends upon the time T years after the start of drilling. The company decides to use a model to estimate the daily volume of oil that will be extracted. The model includes the following assumptions. So the initial daily volume of oil extracted from the oil field will be 16,000 barrels. The daily volume that will be extracted exactly 4 years after the start of drilling will be 9,000 barrels. The daily volume of oil extracted will decrease over time. The diagram below shows the graphs of two possible models. So the one on the left is a linear model and the one on the right is exponential. So part A, part 1 says use model A to estimate the daily volume of oil that will be extracted exactly 3 years after the start of drilling. Okay, so using model A, which is linear, by this the decrease from year to year is going to be exactly the same. So if we find the difference between 16,000 and 9,000, so that's 7,000. Now that means that each year it's going down by 7,000 divided by 4. So 7,000 divided by 4 is a number 1750. So, we can either subtract 3 lots of 1750 from 16,000, or just add 1 lot of it onto 9,000. So 9,000 is the amount after 4 years. 1 year previously, they're going to have been extracting 1,750 more. So, 9,000 and 1,750 is 10,750. So that's the answer to part A, part 1. Part 2 wants us to write down a limitation of model A. So, we can even see it on the graph, and that is this bit over here. So what we could say is, after a certain number of years, the model predicts negative volume of oil being extracted, which makes no sense. That would mean technically that you're putting oil back into the oil field. I think we could also mention as well that it predicts a constant rate of decrease, which in real life probably isn't the case. Okay, then B part 1 says, using an exponential model and the info given in the question, find a possible equation for model B. Okay, so with model B, we can see it's exponential, although it's exponential decay. So what's happening is, instead of exponential growth, we have exponential decay. So that means the power of E in the model is going to be negative. So we could first of all suggest something like could first of all get a pen out. Okay, so we could use something like A e to the minus kt. So, what we then need to do is find the value of A and the value of K. Now, A is easy because we know that when we should also say V is equal to A e to the minus kt. My bad. Right. So, we know when t is equal to 0, the question tells us V is 16,000. Now that means then that 16,000 is equal to A e to the 0. E to the 0 is 1. So 16,000 is A. So up to there, we can now say then that V equals 16,000 e to the minus kt. So now we can find the value of k using t equals 4. So we know when t is 4, v is 9,000. So okay, let's go over the page. So that's going to give us 9,000 is equal to 16,000 e to the minus 4k. Now, if we divide by 16,000, we can get 9 over 16 is equal to e to the minus 4k. Take logarithms, we get log of 9/16 is equal to minus 4k. Now, if we divide through by minus 4, we get k is equal to minus a quarter log of 9/16. So, let's see what we get. Okay, so that, if we go to 2 sig figs, gives us k equals 0.14. Therefore then, our model is that v equals 16,000 e to the minus 0.14 t. Cool. Okay, then part 2 wants us to using your answer to be part 1, estimate the daily volume of oil, and that will be extracted exactly 3 years after the start of drilling. Okay, so all that we're doing there then is substitution. So t equals 3 gives v is equal to 16,000 e to the minus 0.42. So that is going to give us 10,512.7, so I'm going to round that up to 10,513. Cool. One thing to look out for here is that your answer probably won't be exactly the same. It depends on your level of rounding. So when I found the value of k, I only put it to 2 decimal places. If you've gone further, your answer would be more accurate. But as long as you follow through with your model, you get the marks. So this would be absolutely fine. In number 7, we have some vector fun, so it's 5 marks, so quite big. And figure 2 shows a sketch of a triangle ABC. Given that A to B is 2i add 3j add k, and B to C is I minus 9j add 3k, we want to show that angle BAC is 105.9 degrees to 1 decimal place. Okay, so let's track down the angle. So BAC is this chap here. Now then, there is a nice way that we could do this with some vector magic, but you don't get taught it anymore at A level. I think you're doing further, but not pure. So we can't go down that route. So we're in a non-right-angled triangle. We can work out 2 lengths using magnitude of vectors. We're also going to need then a 3rd length, and then we can use the cosine rule. So what I'm going to do is write these vectors in column form first of all, because I think they look less scary. So A to B is going to be 2, 3, 1. B to C is going to be 1 minus 9, 3. Okay, well we also need to work out them. So we've got A to B, we've got B to C, we're going to need A to C. Now we can get A to C by going along A to B and then along B to C. So we can say then A to C is A to B add B to C. So you just add the column vectors together. So that's going to give us 3. 3 minus 9 is minus 6. And 1 add 3 could very well be 4. Okay, so now we know all 3 vectors. So what we now need are the lengths, or the magnitudes of these vectors. So the magnitude of AB is square root of 2 squared add 3 squared add 1 squared which is 4 add 9 add 1, which is root 14. So let's put that on the diagram. So that's this length. Do the same for BC. So that's going to be the square root of 1 squared add 9 squared add 3 squared. Doesn't matter that it's minus 9 because we're going to square it. So 1 squared is 1, 9 squared is 81, so that's 82. 3 squared is 9, 82 add 9 is 91. So that's this length. And then finally AC. So that's going to be root 3 squared is 9, 6 squared is 36, so that's 45. 4 squared is 16, so that's 61. Okay, so that then is this length. Okay, so now that we know those 3 lengths, it's now just cosine rule. So if we call this angle, it's already called A, so that's nice. We're going to call this side little a, and then the other two don't matter, but we should label them, I suppose, in terms of the angles. So then, by the cosine rule, root 91 squared, which is 91, is equal to root 61 squared add root 14 squared, so that's 61 add 14, which is 75, minus 2 root 61 root 14 cos of the angle. Always manage to run out of room. Okay, so cos of A. Now then. Okay, from here I'm going to do 2 things. I'm going to add the cos term to both sides and subtract 91. So that's going to give me 2 root 14 root 61 cos of A is equal to 75 minus 91 is minus 16. Now if we divide through by 2 root 14 root 61, we get cos of A is equal to minus 8 over root 14 root 61. Inverse cos that, so we get A is the inverse cos of minus 8 over root 14 root 61, and that gives us 105.88 blah blah blah, which is 105.9 degrees to 1 decimal place. Boom. Okay, number 8. F of x is a log of 2x minus 5 add 2x squared minus 30, where x is greater than 2.5. So I'm going to point out here, if x was 2.5, there would be a problem, because then you would have a log of 0, which you can't do. Part A wants us to show that f of x is equal to 0 as a real root alpha in the interval 3.5 to 4. Okay, so first thing that we need to mention, it's 2 marks. So the first thing we need to mention is that in the interval f of x is continuous. So again, the only problem would come in if x was 2.5 or less, because then the log, or the thing in the log, would be negative. For values of x greater than 2.5, there's no problem. So, part A, we should say f of x is continuous in the interval and then the way that you find a root or show that there is a root is you're looking for a change of sign between the two values of the function when we substitute in the bounds of the interval. So f of 3.5 make sure for that you can get minus 4.8 and then f of 4 make sure you can get 3.1. So there is a change of sign. Which means there is a root in the interval. Okay, then for part B, we are told that a student takes 4 as the first approximation to alpha. Given that f of 4 is 3.099 and f dashed 4 is 16.67 for sig figs, part B wants us to apply the Newton-Raphson procedure, wants to obtain a second approximation for alpha, giving your answer to 3 sig figs. Okay, so we are given Newton-Raphson in the formula sheet, which is linked down below. So the Newton-Raphson method for solving f of x equal to 0 is that xn add 1, so the next approximation is given by xn minus f of xn over f dashed of xn. So if we say then that x0 is equal to 4, the f of x0 is f of 4, so that's 3.099. And the f dashed of x0 is 16.67. Then x1 is equal to 4 minus 3.099 over 16.67, and to 3 sig figs we get 3.81. Okay, then for part C, we want to show that alpha is the only root of f of x is equal to 0. So, how in the world are we going to do that? There's no nice algebraic way to do it. So, what we're trying to solve is log of 2x minus 5 add 2x squared minus 30 is equal to 0. Now the way that we're going to need to do this is by sketching both, or turning this into two different graphs. So the way we're going to do that is add 30, subtract 2x squared, so then we're left with a log of 2x minus 5 is equal to 30 minus 2x squared. Okay, so what we're going to be sketching then is, so we're going to sketch y equals log of 2x minus 5 and y equals 30 minus 2x squared. And hopefully what we will see is that the two graphs only cross once, which will be at alpha. So, let's think about log of 2x minus 5 first. So, log graphs, draw some axes. So log graphs, well, they are the inverse of exponentials. So exponentials look like that. Inverse graphs are reflected through the line y equals x. So that gets reflected like that. Now to find the x-intercept, we set a log of 2x minus 5 equal to 0, exponentiate, then we get 2x minus 5 is equal to e to the power of 0, which is 1. From that, we can get x equals 3. So the x-intercept down here is at 3. Okay, then we need to think about the x-intercepts of 30 minus 2x squared. So we know that's going to be an unhappy quadratic because it has a negative x squared term. So if 30 minus 2x squared is equal to 0, we can get x squared is equal to 15. And then square root x is plus or minus root 15. Now we know root 15 is going to be just less than 4 because root 16 is 4. So we know then that this graph is going to be hard to draw. So it's going to do something like that. Now this point here would be root 15. So somewhere just to the right of that would be 4. Point here where the two graphs meet is alpha, so we should now finish this by saying the graphs only intersect once, therefore alpha is the only solution. Okay, number 9 wants us to prove that tan theta and cot theta is identical to 2 cosec 2 theta, where theta is not equal to n pi over 2, where n is an integer. Okay, so let's start with the left hand side. So we have tan theta and cot theta. Now, tan is sine theta over cos theta. And cot is 1 over tan, so that's cos over sine. Okay, now we want to turn this into a single fraction. So use whatever method you use. Personally, I use the cross multiplication method. So I would get sine squared add cos squared over sin theta cos theta. Now, sin squared add cos squared is of course 1, so this is equal to 1 over sin theta cos theta. Now, we also need another identity, and that is that sine of 2 theta is equal to 2 sin theta cos theta. So, sin theta cos theta is equal to 1/2 sin 2 theta. So, we then have 1 over sin 2 theta over 2 which is 2 over sine of 2 theta. Which is 2 cosec 2 theta. Boom. Okay, then for part B, says, hence explain why tan theta add cot theta equals 1 has no real solutions. Okay. So, we now know then that tan theta add cot theta is equal to 1, tells us then that 2 cosec 2 theta is equal to 1. Now that means then that 2 over sine of 2 theta is equal to 1. Now, that then means that we will get 2 is equal to sine of 2 theta. Now, sine values can only be between -1 and 1. So we can see at this point that if we try to inverse sine both sides, it wouldn't work because we have 2 on the left. So we should then say something like the range of sine values lie between minus 1 and 1. So there are no solutions. Okay, number 10. Given that theta is measured in radians, we want to prove from first principles that the derivative of sine of theta is cos of theta. We may assume the formula for sine of A plus or minus B, and that as h tends to 0, sine of h over h tends to 1, and cos of h minus 1 over h tends to 0. Okay, so first up we are given a differentiation from first principles, so there it is. Now the very first thing we need to do is to find f of x. So let's say let f of not x, because we're playing with theta, so let f of theta equal sine of theta. And then f of theta plus h is equal to sine of theta plus h. Okay, so I'm not going to get the derivative involved yet, just to cut down on notation. So I'm now going to say then that f of theta plus h minus f of theta all over h is equal to sine of theta plus h minus sine of theta all over h. Okay, now at this point we need to use the compound angle formula for sine of A plus B. So, very conveniently, that is here. So, sine of A plus B is sine A cos B add cos A sine B. So, we can say then that this is equal to sine theta cos h add sine of h cos theta minus sine of theta all over h. Okay, now at this point we want to try and form fractions involving sine of h over h and cos of h minus 1 over h. So, what we can do is factorise the top a bit. So there are two sine of theta terms. So we have sine of theta times cos of h, and then we also have this minus sine of theta there. So inside the bracket, that's going to give us minus 1. And then we have add sine of h cos theta. And again, that's all over h. Now, we can split this fraction into two separate fractions. So we can say this is sine of theta actually let's write it in a different order. So we can say this is cos of h minus 1 over h times sine of theta and then add sine of h over h cos of theta. So then we can say then that the derivative, so df by d theta is equal to the limit as h tends to 0 of all of that. Now, as h tends to 0, we know that cos of h minus 1 over h times sine of theta. Well, we know that cos of h minus 1 over h tends to 0. So that all tends to 0. And sine of h over h cos of theta well, sine of h over h tends to 1, so that tends to cos theta. Therefore, df by d theta does indeed equal cos of theta. Okay, number 11. An archer shoots an arrow at a height 8 meters of the arrow above the ground is modelled by the formula h is equal to 1.8 add 0.4 d minus 0.002 d squared, where d is greater than or equal to 0. Where d is the horizontal distance of the arrow from the archer measured in meters. Given that the arrow travels in a vertical plane until it hits the ground, part A says to find the horizontal distance travelled by the arrow as given by this model. Okay, so that means then we want to find the value of d when h is equal to 0, because we want it to hit the ground. Now remember, it's not going to start on the ground, it's going to start being held by the archer. So that's actually the value of the 1.8. That's the initial height of the arrow. So, for part A then, we want to find d when h is 0. Now that means then we are solving minus 0.002 d squared add 0.4 d add 1.8 is equal to 0. Okay, lovely. So, first of all, I'm going to multiply through by minus 1 to get a positive d squared term. So, we're going to get 0.002 d squared minus 0.4 d minus 1.8 is equal to 0. Now at this point, look at how disgusting it is. Really now we want to use the quadratic formula. So we're going to use it with a is equal to 0.002 b is minus 0.4 and c is minus 1.8. So we're going to get d is equal to positive 0.4 plus or minus the square root of technically minus 0.4 squared, but that's exactly the same as positive 0.4 squared. And then minus 4 times 0.002 times minus 1.8. So that's going to be a positive. Then we could multiply one of the things by the 4. So we're going to go 0.008 times 1.8. And then that's all over 2a. So that's all over 0.004. Okay, so having put that through my calculator, we only want the plus the square root value. The other one, when we use the minus, gives us a negative value. So we get d is equal to 204.4 blah blah blah. I think that then we would be fine using 204 meters. The reason d can't be negative is that would mean the archer is shooting the arrow behind him, which would be silly. So that's the answer to part A. Part B says, with reference to the model, interpret the significance of the constant 1.8 in the model. So I've already said that when d is equal to 0, so when the archer is holding the arrow, you would just get h equals 1.8. So the 1.8 is the initial height of the arrow when the archer is holding it. Okay, then part C answers to write 1.8 add 0.4d minus 0.002d squared in the form a minus b lots of d minus c all squared, where a, b and c are constants to be found. So this one is completed square form. So this is going to be disgusting because we have horrible numbers, but we can do this. So we have 1.8 add 0.4d minus 0.002d squared. Now, to be able to complete the square, you need to have a single positive squared term, which we don't. We have a minus 0.002 squared term. So, what we're going to do is factorize out minus 0.002. Now, it might also help if we write that as a fraction. So 0.002 is 2 1,000ths, which is 1/500th. So that should make proceedings a little bit nicer. So we're going to take out the front a factor of minus 1/500th. So some teachers will tell you to only do it on the d terms. Do it on the whole thing, it's a lot less complicated. So all that we're doing now is inside, let's use square brackets. So inside the square brackets, because we've divided, or we've taken out a factor of minus 1 over 500, we need to multiply everything inside by minus 500. So, we are now going to get 1.8 times minus 500, and that is minus 900. Now 0.4 times minus 500 is minus 200. So we got minus 200d. And then add 1d squared. Now if we write that in descending powers of d, we have d squared minus 200d minus 900. Okay, so now inside of the square brackets we can complete the square. So we're going to have d minus 100 squared, and then we got minus 900 on the outside, and then we also have to subtract 100 squared. Now 100 squared is 10,000. So we have minus 1 over 500 times d minus 100 squared minus 10,900. Okay, so what we now need to do is multiply through by the minus 1 over 500. So, it can't get inside of the squared brackets, so all it's going to do there is sit on the outside. What it is going to do is multiply the minus 10,900. So, 10,900 divided by 500 is 218. So, we're going to get then 21.8 and then minus 1 over 500 times d minus 100 squared. Now at this point we can turn the 1 over 500 back into 0.002. So we get minus 0.002 times d minus 100 squared. So that's the answer. I'm going to throw in some bonus info here. So remember, the whole point of completing the square is to find the maximum or minimum value and the x coordinate at which it occurs. So here we know then that the maximum height is 21.8 meters, which occurs when d is equal to 100. Okay, next up, it is decided that the model should be adapted for a different archer. The adapted formula for this archer is h equals 2.1 add 0.4 d minus 0.002 d squared. So something to notice here, the only thing different is the starting height. For our first archer it was 1.8, for this archer it's 2.1, and the rest of it is exactly the same. So we are then asked hence or otherwise find for the adapted model one the maximum height of the arrow. So because the d and d squared part are exactly the same, to write this in the completed square form we would do exactly the same as we just did above, so we don't need to do it again. All that we need to do is add on 0.3 to our maximum height that we found for the old model. So d bar 1 is just 21.8 add 0.3, which is 22.1 meters. Okay, and then part 2 wanted us to find the horizontal distance from the archer of the arrow when it is at its maximum height. So because the d and d squared part are exactly the same, it's going to be at the same value of d as for our archer above. So it's just, again, at d equals 100. Cool. Okay, number 12. In a controlled experiment, the number of microbes n present in a culture 2 days after the start of an experiment were counted. N and t are expected to satisfy a relationship of the form n is equal to a t to the b, where a and b are constants. Part A wants us to show that this relationship can be expressed in the form a log 10 of n is equal to m log 10 of t add c, giving m and c in terms of the constants a and or b. Okay, so we're going to start then with n is equal to a t to the b. Now we're going to take the log of both sides. Now when you only write a log with no base, it is log base 10. So just to cut down notation, I'm just going to write a log without the 10. So log n is equal to log of a t to the b. Now by the rows of logs, we can split the right hand side. So we can say log n is equal to, now I'm going to write it as log t to the b, add log a. So that's just using the addition law of logs. If you add them together, you multiply the stuff in the log. So we're doing that backwards. And then by the rules of logs, log t to the b is equal to b log t. So we can get log n is equal to b log t add log a. So, comparing their things to our things, we have m is equal to b, and c is equal to log a. Okay then, next up, figure 3 shows the line of best fit for values of log base 10 of n plotted against values of log base 10 of t. Part B, one says to use the information provided to estimate the number of microbes present in the culture 3 days after the start of the experiment. Okay, so what we're going to need to do is use the graph and what we've done in part A to find the values of A and B, and then substitute t equals 3 into the model. So, first up then, remember that we found that c, the y-intercept, or here the log base 10 of n-intercept, is log a. So, if we go to the graph and find the value of the intercept, so every 10 little squares represents 0.5, so I would say that's about 1.8. So, that then tells us log 10 of A is equal to 1.8. Now that then means then that A is equal to 10 to the power 1.8. Now if we go to the nearest whole number, that gives us 63. And then in our model, we found that m, the gradient, was b. So to find b, we need to find the gradient of the line. So b is, so we need to find two nice points, so we might as well use this one. So this point is 1.8. See if we can find another nice point. Part C wants us to explain why the information provided could not be reliably used to estimate the day the culture first exceeds 1 million. Okay, so when n is equal to 1 million, log base 10 of n would equal 6. Now if we look at the graph, we can see the highest plotted point was at 4.5. So remember that we're dealing with powers of 10, so 1 million is almost 100 times the size of the culture at this point. So we can't just assume that the graph is going to carry on constantly. So we can't just assume the growth of the culture will carry on with this trend. So it might get to a point where the culture has taken up all of the space that they can take up and they can't expand anymore. Or they might get to a certain point where their growth becomes exponential. Basically, we can't rely on this model indefinitely for any given period of time. Okay, then for part D, with reference to the model, interpret the value of the constant A. Okay, so remember we worked out A was 63 and our model N is 63 times T to the power 2.3. Now, A is not the initial number of microbes. When T is equal to 0, N is equal to 63 times 0 to the power 2.3, so that's just 0. When T is equal to 1, however, N is 63 times 1 to the power 2.3, so A is the number of microbes 1 day after the start of the experiment. Okay, number 13, we have more fun with parametric equations. So the curve C has parametric equations x equals 2 cos t and y is root 3 cos of 2t, where t is greater than or equal to 0, less than or equal to pi. Part A, one says to find an expression for dy over dx, dy by dx in terms of t. Okay, so for that we need to differentiate x and y in terms of t. So x is 2 cos t. So dx by dt is equal to minus 2 sine t. And then y is root 3 cos of 2t so dy by dt is So using the chain rule, we differentiate to t and we get 2. So 2 times then the derivative of cos, which is minus sine. So we get minus 2 root 3 sine of 2t. Now dy by dx is equal to dy by dt times dt over dx. Now that is going to give us minus 2 root 3 sine of 2t over minus 2 sine of t Now the minus 2's cancel out, so we get root 3 sine of 2t over sine of t. Now, even though that is exactly right, we can actually make this a lot nicer. Sine of 2t is 2 sine t cos t. So this is 2 root 3 sine t cos t over sine t, which is then finally 2 root 3 cos t. Okay, then part B, we are told the point B lies on C where t is equal to 2 pi over 3. The line L is the normal to C at B. We want to show that an equation for L is 2x minus 2 root 3y minus 1 is equal to 0. 5 marks. Okay. So, let's think about what we need for a normal. We need to know the gradient of the curve at the point. From that, we can get the gradient of the normal. We also need to know the coordinates at the point. And then we can either use y equals mx add c, or y minus y1 is equal to m times x minus x1 to get the equation. So, remember that we've worked out dy by dx, that is the gradient of the curve. So, the first thing I'm going to find is the gradient of C at B. So, I'm just going to call this M C at B. To get that, we shove in t equals 2 pi over 3 into our derivative. So that's going to be 2 root 3 cos of 2 pi over 3. And that is going to give us minus root 3. So, gradient of the normal is the negative reciprocal of that. So it's positive 1 over root 3. Which we can rationalise to root 3 over 3. Okay, so we now know the gradient of the normal. We now need the x and y coordinates. So at P, x is equal to 2 cos of 2 pi over 3 now that just gives us minus 1, so that's nice. And y is equal to root 3 cos of 4 pi over 3. And that gives us minus root 3 over 2. Okay, so I'm going to use y minus y1 is equal to m times x minus x1. So L is of the form y add root 3 over 2 is equal to m, so the gradient was root 3 over 3 times x minus 1, so that's x add 1. Okay, so now we just need to do some magic to this. So if we expand the brackets, we're going to get y add root 3 over 2 is equal to root 3x over 3 add root 3 over 3. Okay, right then. Let's just take a look at what we're trying to find again. Okay, so notice there are no fractions. So, if we first of all copy and paste this, okay, so I'm going to get rid of the fractions. So if we multiply through by 3, we're going to get 3y add 3 root 3 over 2 is equal to root 3x add root 3. If we then multiply through by 2, we're going to get 6y add 3 root 3 is equal to 2 root 3x add 2 root 3. Okay. Okay, so at this point, it might be worth taking a look at where we're trying to get to again. We're on track, so we want a positive x term and a negative y term, and a negative constant. So, what I'm now going to do is move everything over to the right. So, we're going to have 0 is equal to 2 root 3x minus 6y, and then we got 2 root 3 minus 3 root 3, so that's minus root 3. Now, we can also stick an equals 0 on the end there. So, if we now divide through by root 3, we get 2x, that's good, minus 6y over root 3, minus 1, also good, is equal to 0. Now if we rationalise the 6 over root 3, we get 2x minus 6 root 3 y over 3 minus 1 is equal to 0, and then finally 2x minus 2 root 3y minus 1 is equal to 0. Boom. Okay, then we're told the line L intersects C began at the point Q. Find the exact coordinates of Q. 6 marks. Probably really easy then. So, simultaneous parametric equations. What a good time. So, all we know is at intersection points, x and y have to be equal to these guys. So we know x has to be 2 cos t, and y has to be equal to root 3 cos of 2t. So, what we're going to do is substitute these into the equation for L. So, we're going to get that 2x, so that's 4 cos t, minus 2 root 3y, so that's minus 2 root 3 root 3, so that's minus 6. cos of 2t minus 1 is equal to 0. Okay, so our job now then is to solve this good times. Okay, so we need to get rid of the cos of 2t. Now, cos of 2t is cos squared minus sine squared. So, we can get 4 cos t minus 6 lots of cos squared t minus sine squared t minus 1 is equal to 0. Now we need to get rid of the sine squared. So we know that sine squared add cos squared is equal to 1, so sine squared is 1 minus cos squared. So this then is 4 cos t minus 6 lots of cos squared minus 1 minus cos squared. So that's going to give us 2 cos squared minus 1 minus 1 is equal to 0. So now we have 4 cos t minus 12 cos squared of t add 6 minus 1, so that's add 5 is equal to 0. Now, if we rearrange this slightly and make the squared term positive, we can get 12 cos squared of t minus 4 cos t minus 5 is equal to 0. Okay then, so at this point we now want to try and factorize this. So with a little bit of playing around, so I was thinking, well, two numbers need to multiply together to give us minus 5, so that's a mixture of positive or negative 1 and 5. So I thought, well, 5 times 2 is 10, and then that would leave us with 1 times 6, which would give us 6. So, given that we need a minus 4 in the middle, we're going to have a 2t there, a 6t, sorry, cos of t, so 2 cos t and 6 cos of t. Now, if we stick a minus 5 there, we're going to need a plus 1 there, and that works. So that tells us then either 2 cos of t minus 1, sorry, plus 1, 2 cos of t plus 1 is equal to 0, which leads us to cos of t is equal to minus 1/2. But that's what we were playing around with in part B, so we're not interested in that one. What we are interested in is in that 6 cos t minus 5 is equal to 0. That leads us to cos of t is equal to 5/6. Now remember, we're not trying to find the value of t, we're trying to find the values of x and y. So, now that we know that cos t is 5/6, we can use the parametric equation for x. So we know that x is 2 cos t. So, we know then that x then is equal to 2 times cos t, so 5/6, which is 5/3. So that is the x coordinate at Q. Now y, well, the parametric equation for y is in terms of cos 2t. Now we could use that, but we could also use the equation for L, which is what I'm going to do. So, we now know that x is 5/3. So using this, we get 10/3 minus 2 root 3y minus 1 is equal to 0. So if we add 2 root 3y to both sides and do 10/3 minus 1, we get 7/3 is equal to 2 root 3y. If we divide by 2, we run out of room. We get 7/6 is root 3y. And then if we divide by root 3, we get y is 7/6 root 3. Which is 7 root 3 over 18. So finally the coordinates of Q are 5/3, 7 root 3 over 18. Good times. Number 14, figure 4 shows a sketch of part of the curve C with equation y equals x squared log x over 3 minus 2x add 5, where x is greater than 0. The finite region S, shown shaded in figure 4, is bounded by the curve C. The line with equation x equals 1, the x-axis, and the line with equation x equals 3. The table below shows corresponding values of x and y, with the values of y given to 4 decimal places as appropriate. Part A wants us to use the Trapezium Rule with all the values of y in the table to obtain an estimate for the area of S, giving your answer to 3 decimal places. Okay, so we're given the Trapezium Rule, so it's this guy. The integral of y between a and b with respect to x is 1/2 h lots of y0 add yn add 2 times the other y values, where h is b minus a over n. So all this is use of formula. We need to spot that h is 0.5, so that's the difference in the x values. Y0 is 3, and yn, the final y value is the 2.2958. So to speed things up, I've already done this. There is the Trapezium Rule with the values, and hopefully you can get 4.393. Okay, then part B just wants us to explain how the Trapezium Rule can be used to get a more accurate estimate for the area of S. So that comes down to just using more trapeziums with a smaller value of h. And part C, the real fun bit, wants us to show that the exact area of S can be written in the form a over b add log c, where a, b and c are integers to be found. Okay, so the area then is the integral of the function between 1 and 3. So we should start by writing the area is the integral between 1 and 3 of x squared log x over 3 minus 2x add 5. Okay, so obviously the only real problem is integrating x squared log x over 3. So we're just going to deal with that bit first of all. So for the integral of x squared log x over 3, we are going to use the integration by parts. Now we're given this in the formula sheet, so the integral of u times dv by dx with respect to x is uv minus the integral of v du by dx with respect to x. So, we always call u the thing that is easiest to differentiate or hardest to integrate. So we're going to call u log x. So that makes du by dx 1 over x. Now we're going to call dv by dx x squared over 3. So then v is x cubed over 9. So then the integral is uv, so 1 over x times, log x times x cubed over 9, so that's x cubed log x. All over 9 minus the integral of v du by dx. So that's x cubed over 9 times 1 over x. So that's x squared over 9 with respect to x. So that then is x cubed log x over 9 minus the integral of x squared over 9, so that's x cubed over 27. Now, because this is part of our definite integral up above, I'm not going to worry about the plus c. So, we can now say then that the area is, so now we're going to integrate everything. So we've got what we've just done. So x cubed log x over 9 minus x cubed over 27. And then the integral of minus 2x add 5. So that's minus x squared add 5x. Between 1 and 3. Okay, so we are going to get then forgot the limits. So we are going to get then 3 cubed log 3 over 9. So that's 27 log 3 over 9. So that's 3 log 3. And then we're going to get minus 3 cubed over 27, so that's 27 over 27, that's minus 1. Then we're going to get minus 9, add 15, and then when we whack 1 in, quite nicely, a log of 1 is 0. So that first term disappears. So then we get minus 1/27 minus 1 add 5. Okay, so we have 3 log 3, minus 1 minus 9 add 15 is 5, and then we have minus a 27th, so that's add 1/27. Now, inside of that bracket, we have minus 1 add 5, so inside of the bracket, that's a plus 4, but we're subtracting on the outside of the bracket, so that's minus 4. Now, by the rules of logs, 3 log 3 is log of 3 cubed, which is log 27. Now we have 5 minus 4, which on a good day is 1. So we have add 1/27. So altogether we have 28/27. Add log 27. Good times. By 15 we're at the end, and I would say that we've had worse than this question. So figure 5 shows a sketch of the curve with equation y equals f of x, where f of x is equal to full sine of 2x over e to the root 2x minus 1, for x between 0 and pi. We are told the curve has a maximum turning point at P and a minimum turning point at Q, as shown in figure 5. Part A wants us to show the x coordinates of point P and Q. Our solutions of the equation, tan of 2x is equal to root 2. Good times. Okay, so it's only 4 marks. So at turning points, the df by dx is equal to 0. So what we need to do is find df by dx, set it equal to 0 and solve for x. Although we don't actually need to solve, we just need to get down to 2x is equal to root 2. So our function then is 4 sine of 2x over e to the root 2x minus 1. So short-term memory for sine 2x over e to the root 2 x minus 1. Okay, so to differentiate this, we're going to need to use the quotient rule. Now we are given this. It's in terms of f and t, but we're going to be using u and v. So we're going to say that u equal 4 sine 2x, and then u dashed is equal to 8 cos 2x and then v is e to the root 2x minus 1. So then v dash is, well, we differentiate the power, which is just going to give us a root 2, and then it's just times the function. So it's root 2 e to the root 2x minus 1. Good times. Okay. So then, df by dx for us, so ours is going to be u dashed v, so that's 8 cos 2x times e to the root 2x minus 1 and then it's minus v dashed u, so root 2 now let's try this as, so it's root 2 e to the root 2x minus 1 times 4 sine of 2x. So I'm going to put the 4 for the 2 and then the sine of 2x and then the e to the root 2x minus 1. Okay, and then that is all over v squared. So that's all over. Now don't worry about faffing around with it, because remember in a minute we're going to set this equal to 0 so we can get rid of the denominator straight away. So it's e to the root 2x minus 1 squared. So that is our derivative. Isn't it lovely? So what we're now going to do is set this equal to 0. So we can start to make it a lot nicer, I promise. So if we set this equal to 0, straight away, as I just said, we can multiply through by the denominator, so we then get left with 8 cos of 2x e to the root 2x minus 1 minus 4 root 2 sine of 2x e to the root 2x minus 1. And that is all equal to 0. Okay, the next thing we can do, which is very nice, is we can divide this horrible exponential away. So we then get left with 8 cos of 2x minus 4 root 2 sine of 2x is equal to 0. We can then divide through by 4, so we get 2 cos 2x minus root 2 sine of 2x is equal to 0. Okay, now remember that we want to get a tan of 2x involved, so if we now divide through by cos of 2x, we get 2 minus root 2 tan of 2x is equal to 0. And then we can add root 2 tan x to both, root 2 tan 2x to both sides. So we get 2 equals root 2 tan of 2x divided by root 2. We get 2 over root 2 is equal to tan 2x. If you rationalise the denominator, then you get 2 root 2 over 2, which is just root 2. So root 2 is indeed tan of 2x. Boom. Okay, then for part B, using your answer to part A, find the x-coordinates of the minimum turning point on the curve with equation part 1, y equals f of 2x. Okay, so to do this, we're going to first of all find the x-coordinates of the maximum and the minimum on the normal curve. So, we know these x-coordinates are solutions to tan of 2x equals root 2. Now from that, we know then that 2x is equal to the inverse tan of root 2. Now, if we inverse tan root 2, we get, first of all, 2x is equal to 0.955. And to get the next one for 2x, we add pi because the period of tan is pi. So we also get 4.09. Now that means then that x is 0.478 and 2.05. So now we know the x-coordinates of each turning point. So this one is 0.478. And this one is 2.05. Now, f of 2x f of 2x is a squash or a stretch. So it does squash things together, really we should call it a stretch. Scale factor 1/2 along x. So, what I was going to do is move this x-coordinate, remember it's the minimum that we want, so it's just going to half it. So, the x-coordinate of the minimum is 2.05 over 2, which is 1.025. Okay, then for B part 2, we want y is 3 minus 2f of x. So we need to think about what that is going to do to the graph. So multiplying the function by minus 2 is going to stretch it with a scale factor of 2 and reflect it in the x-axis. So the minimum is now going to be the first turning point. So the graph is now going to look something like that, except for the bit at the end. Should have kept going like that. And then the 3 at the start means that we're translating the graph up by 3. So, all told, it would look something like that. Where we can now say this is 3. What we really care about there is that, aside from my terrible drawing, the minimum is just directly below where the maximum was. So the coordinate now of the minimum is 0.478. Boom. And on that, guys, paper 1 is done. Hope you found it useful. Pretty hard, particularly here, towards the end. I'll put the playlist down below as top comment with all 3 sample papers, and remember, all of my past papers and other content is down below in the description. Don't forget to give us a thumbs up, get subscribed, drop us a comment with any requests. Take it easy, take care.